Hello and welcome to another episode of Humans in 5.
We know we said we'd try not to endlessly talk about COVID-19. There's plenty of coverage on that, but we finally have some great news to share on this pandemic. A vaccine for the coronavirus that has been plaguing us has been developed and is already being rolled out.
In honor of this huge occasion, we thought we might take a closer look at this vaccine and at the whole vaccine phenomena.
A vaccine is a prepared injection of a very small amount of disease-causing agent, like a virus, that is introduced to the immune system. The immune system recognizes that very small amount of a virus and mounts an immune response to it, learning what the virus looks like so it can better defend the body against it when it should meet the virus again. Vaccines are usually made of a very weakened or inactive version of a disease-causing agent so as to not make you really sick.
Vaccines aren't a new idea. Some historical texts suggest that vaccines were already being used as a means to fight disease in China and India in the 1500s. In 1796, English doctor Edward Jenner used a small amount of cowpox to create immunity to smallpox. His method underwent medical and technological changes over the next 200 years and eventually resulted in the eradication of smallpox. From this point forward, vaccines revolutionized human health.
There are multiple examples of the effectiveness of vaccines, but here's one to consider. Poliomyelitis is a disease caused by a poliovirus, which will start as a viral flu and may develop into muscle paralysis, eventually impacting people's ability to breathe. A polio vaccine was licensed in the United States in 1955. During 1951 to 1954, an average of 16,316 paralytic polio cases and 1,879 deaths from polio were reported each year. Polio incidence declined sharply following the introduction of a vaccine to less than 1,000 cases in 1962 and has remained below 100 cases after that year. As of 1991, polio caused by the wild-type virus has been eliminated from the Western Hemisphere.
Now, why don't we have a closer look at how a vaccine works? Vaccines deliver what's known as a pathogen imposter to the immune system. It looks like a specific pathogen, but doesn't make you sick. Pathogens are covered with molecules called antigens, which work to trigger a specific immune response. Special immune cells find this pathogen imposter via its antigens, consume it, and display the antigen on the outside of the cell.
These immune cells head to an immune center in the body, like the lymph nodes, and display the antigens to cells that don't recognize this pathogen. These naive cells learn to recognize the antigen, spread the word to other immune cells, and create an antibody for the pathogen, which is a protein that's used to fight pathogens in the body.
The COVID-19 vaccine is a little bit different to other vaccines. It's what's known as an mRNA vaccine. Viruses contain a core of genes made of DNA, deoxyribonucleic acid, or RNA, ribonucleic acid, wrapped in a coat of proteins. To make the coat of protein, the DNA or RNA genes of the virus make messenger RNA, also known as mRNA. The mRNA then makes the proteins.
mRNA vaccines work by providing the genetic code of the virus to our cells to produce viral proteins. Once the proteins, which don't cause disease, are produced, the body launches an immune response against the virus, enabling the person to develop immunity. mRNA can theoretically be used to produce any protein, with the upside that it is much simpler to manufacture than the proteins themselves or weakened versions of viruses typically used in vaccines.
Many health authorities and countries have authorized the use of 2 COVID-19 vaccines. The companies creating one of them, Pfizer and BioNTech, said that they identified 94 cases of COVID-19 among 43,538 trial participants. These results suggest that the vaccine was more than 90% effective at preventing disease, when measured at least 1 week after trial participants had received a second vaccine dose 3 weeks after the first.
There's a lot more for us to unpack about vaccines and how we discuss them in science and the wider world. But for now, we want to give a huge thank you to the many researchers who worked so hard for this vaccine victory.
Thanks for watching, and we'll see you next time on Humans in 5.
And don't forget to subscribe.